Assalamualaikum everyone and welcome back to my YouTube channel. Today we're gonna start with past paper practice of chapter 1, that was physical quantities and units. Let's start. Okay, so MCQ 1 says that which of the following units are both SI base unit. Okay, so we know that we have 7 SI base unit. Okay, तो we need to figure out कि इनमें से कौन से वो SI weights unit इनमें से वो 7 contain करते हैं या नहीं. So on option A we have ampere. Okay, ampere is correct, but you can see the degree Celsius is not the correct. The degree Celsius is not an SI base unit for temperature. Kelvin is the correct answer. Okay. In second option we have ampere and Kelvin. Both are SI base units, so B would be our answer. You can also check the other options. Coulomb is not. And okay, so both C and D are incorrect. Then moving on to our second MCQ, which states that uh, there are two vectors, okay, and which vector triangle that the vector z to the magnitude and direction of vector x minus y. Okay, so x minus y basically means that you are adding x and minus of y. Okay, so minus of y would be like in opposite direction, like this. We need to add that thing, that vector. Okay, so we know how to add two vectors. We're gonna attach the tail of second to the head of first vector. Okay, so I'm gonna attach minus y like this, and then your this would be your resultant vector z. Okay, so A would be the correct answer. Then question 3, which formula could be correct for the speed, okay, v of ocean waves in terms of density and the acceleration and depth of ocean and the wavelength lambda. Okay, so what we can do is check the units. Okay, you must have remembered the concept of homogeneity. Okay, we need to check the homogeneity in this question. So if the equation is homogeneous, means that answer would be the correct. Okay, so we need to see that ms minus 1 should be on both sides. Okay, so first we're gonna check the first option, that is under root of g and h. Okay, so we know that g unit is ms minus 2, and then we're gonna multiply it with lambda. Lambda is wavelength, which means it has unit of a meter. Okay, so it would be m. This would result in under root of m square s minus 2, and that means if we take the square, okay, so it would result in m minus 1. So yeah, option A is a correct one. Okay, we found the correct option at our first try. So that means that A is the correct equation, okay, or correct formula. Then our next MCQ, uh, very easy, that states that which of the following is a scalar quantity. Okay, so no explanation needed. We know that mass is the scalar quantity, only scalar quantity in the above four options. Then we have next MCQ, which states that the unit of work, the joule, may be defined as work done when point of application force of 1 Newton moved a distance 1 meter in the direction of force. Okay, we know that to express the joule in terms of base unit, okay, mass, length, time. So what we need is simply we need to represent the work done unit, that is joule, in SI base unit. We have done this. Okay, the work done is force into distance. Okay, the forces we know that ma and d. Okay, so m is kg, acceleration unit is ms minus 2, and then we have m. Okay, that is distance. So our final answer would be kg m square s minus 2. So this would be our final answer of this MCQ. Okay, so this MCQ states that two forces, each of 10 Newton, act at a point shown in the diagram. Okay, the angle between is shown already. What we need to do is we need to find the magnitude of the resultant force. Okay, so what can we do here is mm, we can shift this vector to here. Okay, so what I will do is I will shift this vector. Okay, I will draw it like as it is in same tiltness. Okay, it is same tilted. This is 10 Newton. Okay, because I'm joining the head. Okay, this is head of the first vector with tail of the second. Then what we can do is, okay, we know that if this is 60 degree, okay, a line makes 180-degree hole. If this is 60 degree, this angle would also be 60 degree. Okay, and what we can do is then we would join the two vectors like this. Okay, head from first and to the tail. So this would be our resultant vector. Okay, we know that if this is 60, the only option left for this two angles would be 60 and 60. Okay, this shows that this triangle is an equilateral triangle. Equilateral triangle, which means that all the three sides are equal. Okay, the final answer would be 10 Newton. Okay, the resultant would also be a 10 Newton. Okay, then moving on to our next MCQ is student measures a current of 0.5 ampere. Okay, what we need to do is which of the following correctly expresses this result. Okay, we need to check that which of the following makes 0.5 ampere. Okay, the option is 50 milliampere. Milli is what? 10 to the power 3 minus 3. Okay, so this would result in 0.05 ampere, not zero point 0.5 ampere. So first option is not correct. Okay, second option is recipe would correct me. Okay, because we know that it's 50 mega ampere, which means that it's very much greater than our actual value. Okay, so we need to neglect this and this one also. Okay, so we will also left with our option C. Okay, we can also check that. Okay, we have 500 milli. Okay, we need to divide this by the, and it would result 8.5 ampere. C would be our correct answer. Then moving on to next MCQ, which the momentum of an object of mass m is p, which quantity has same base units as p square upon m. The p square upon m. Okay, we can check the unit. Okay, so we know that momentum is what? Mass into velocity. Okay, so p square upon m. Okay, so it would mv whole square upon m. 1 m would be cancelled out, so it would be mv square. Okay, you can most of the students would got an idea that it is somewhat kinetic energy formula. Okay, so it would be kg m square s minus 2. So energy is the quantity which has same unit as this expression. Okay, what is the magnitude? Okay, we have given. Okay, you always do not need to uh, read the whole MCQ. Sometimes it wastes your time. Okay, so what we can do is, okay, OI is given 3 Newton, and then we have OX. Okay, and resultant, this is your resultant vector. So they are asking you to find out the magnitude of OX. What we can do is simply we can shift this vector here. Okay, join it like this. A straight line. This would be a 3 Newton. Okay, now this would make a 90-degree. Now what we can use, we all know that we can use a Pythagoras theorem. Okay, so OX would be under root 5 square, that is hypotenuse, minus 3 square. Okay, that would result in 4 Newton. So 4 Newton would be our answer. Then which pair of contains one vector, one scalar? Okay, very simple question. First two is does not contain one vector, both are vectors. In second, we have one vector. Okay, this both are vectors. Okay, this one is vector, this one is scalar. In C, we have vector and vector, and in D, we have scalar and scalar. So B would be our final answer. So you must know that quantities, whether they are scalar or vector. That's really important. Okay, which of the following could be measured in same units as force? Okay, so first we need to find that what is the unit of force. That is kg ms minus 2. Okay, that is ma. F is equal to mf formula. I have derived from that. So we need to check which of the following contain have the same unit as above. Okay, so energy in divided by distance. Energy unit is kg m square s minus 2 divided by m. And this would, yeah. So our first option is the correct one. Okay, it has the exactly the same unit, SI base unit as force. So this would be our correct answer. Okay, then we have second MCQ which states that what is the name and value of this unit. Microsecond is 10 exponent minus 6. It is correct. Okay. Other are not correct. This one is not correct. Okay. Milli is also not correct. Okay. And they have asked you for this symbol. So you know that this is the symbol of micro. So A would be the correct answer. Then what is the reading shown on this milliammeter? Okay, we can see that there are 4 divisions between, okay, 2 to 4, which is around, which states that 3 would be like somewhere here. Okay, so it's going like zero point 0.4, that this is 2.4, then 2.8, then 3.2, and it's something ahead, so it would be 3.4. Okay, so you need to see the divisions, how much division is. So this one division is of 0.4. Okay. Then we have this equal to 1 picosecond and distance 1 gigameter. Okay, 1 pico, we all know that it's 10 exponent minus 12. Okay, then we gigameter is 9. Okay, tera is its tera. Okay, not its giga. C would be our correct answer. Okay, which of the following definition is correct and uses on quantities rather than units? Okay, density is mass per cubic meter. No, not cubic meters, per volume. Okay, potential difference is energy per unit current. It has used the quantities rather than units, but the formula is not correct. You can see that. Okay, because energy was equal to VIT. Okay, there was time also there. Okay, then pressure is force per unit or area. This one is the correct answer. Okay, it has only quantities. Then this speed is distance per, not second, per time, distance traveled per unit time. Okay, okay, then we have when a beam of light incident travel, the intensity is energy delivered. Intensity is defined as energy delivered per unit area per unit time. What is the unit of intensity? Okay, so we need to find out the intensity unit. It's energy per unit area and time. Okay. So we know that the energy SI base unit is kg m square s minus 2, and below we have m square area and time. So m square would be cancelled out, s would go above, okay, and it would be one subtract, okay. So kg, oh sorry, it would be added, okay, my mistake, it would be added and we would get answer D. Then we have an estimation question. An Olympic athlete of mass 80 kg completes in a 100-meter race. What is the best estimate of mean kinetic energy during the race? Okay, let me do it here. So we know that EK is equal to half m, okay, v square. Okay, so half into 80 is already given. We need to find the velocity, so we can assume, okay, it's an estimate, so I am taking 10 seconds that are athlete, an Olympic athlete at least, so okay, covers in 10 seconds at most a 100-meter race. Okay, so this would result in a reasonable estimate. You can further calculate it and this would give you a reasonable estimate. I think it would be A or B. So, okay, in between. Okay, this one is repeated. Okay, this one is repeated. This one question. Okay, a metal sphere of radius R, tank of water is speed. Okay, then we have given drag force. You just need to identify what is the symbol. What does the symbol represent? Which quantity? Okay, they are asking you to find out the SI base unit of K. So K would be F upon RV. Okay, and F is, we know that F is kg ms minus 2, R is radius means meter, V is velocity m minus 1. Okay, and that would be kg. 1m is denominator, it would come at numerator, it would be minus 1, and then we have minus s minus 1 below, it would become plus 1. When it comes to numerator, this would be like s minus. Okay, C would be our correct answer. Which pair of units are both SI base? Okay, this one is also repeated. We know that ampere and Kelvin are SI base units. Then we have okay, which line correctly indicate the prefixes? We need to identify correct prefixes. 10x, and we know that it's pico. Then 10 it's nano. 8 10 exponent 6 is micro. C would be our correct answer. Okay, which expression of base unit equivalent to volt? SI base unit of volt, we need that. So you can take P equal to VI. We can use that. Okay. So we know that power is, first we need to know that what is power. Power is work done upon time. Work done formula is kg m square s minus 2 upon s. Okay, this would give you kg m square s minus 3. Okay, this is the unit of power we will use here. V is P kg m square s minus 3 upon I. I is ampere. Okay, so the final answer would be A minus 1. Okay, this would be your correct answer, D1. Our next MCQ is ask you to find how many vector and scalar quantities are in this equation. This equation is of work done. We all know that. So we know that work done is scalar. Okay, force is vector, and your S, that is displacement, is also vector. This equation contains one scalar and two vector quantities. Then we have, okay, what is the possible unit for the product VI, where V is potential, I is the. Now we need to look at this possible unit. Okay, so we know that it is equal to power. Okay, power is also equal to VI. Here we need to see the unit of power. Okay, power is work done upon time. Work done is force into S and time. Force is Newton, time S is meter, and time is S. It would be nms minus. Okay, so D could be your correct answer. What is the unit of weight in terms of SI based unit? SI based unit in terms it would be not Newton. Then we have vector P and Q. We need to represent, show that which is B minus Q. The minus Q means that it is like this, so it would be like this. If I join it here, okay, it would be like something like this. Okay, so you know that the direction. So in my opinion, C would be the correct. Then we have what is the approximate temperature of a red hot ring on an electric cooker. So it is an estimate, so you should know that it is in between 500 degrees Celsius to 1000 degrees Celsius. Okay, so D would be the correct answer. So this was all of the unit, chapter 1. Okay, measurement and unit. We will be doing the measurement question MCQs as well in the next video.